see my screen, and this is how this is the website of the application, and then we will explain later how you can log in, etc. I will say that except for the administrators, end users are a very important target for this application, and we can have different groups of end users. And for instance, we can have engineers, which will be more interested in the risk assessment of the assets. We can have social scientists that would be more interested in the social parameters and the social impacts that the failure might have, and or climatologists that can be more interested in the climatic, in the modular climatic data, or the system operators such as Fingrid, which may be interested in the overall risk assessment and impact, the total impact of failures. So let's now begin with demonstrating the platform. And the first step for a user is after the home page, which is provides some information about the project and what is the objectives of the project. Then the user should log in by using credentials that are provided by the administrator. During the demo, one single username and password will be used by all end users of Pilot 2, and it should be clarified that each user can visualize the data of the connected to him her assets. So there is some privacy between the pilots. And let's start. In order to log in, we press the login button and we enter the username. Of course, I will provide that in the chat in the second in the hands-on session. And what I need is to enter the username for this pilot, which is the Fingrid, and the password. And by pressing sign in, I'm logging in and I'm redirected in the home page when you can see a welcome message to the end user. And also there is a video which is is a manual for its pilot. And of course, later on we will end a PDF file which will be the manual for the platform. If you press play on the video, you can see the main steps, the modules and instructions for the end user. And now, if the user press the risk assessment, I will talk about the asset initialization at the end, because today our focus is on the end user. And let's press the risk assessment, which is the first module, and it is more related to the presentation that I made regarding the technical analysis of the tower. After pressing the risk assessment, you are redirected on the map of the area, and we are moving into Finland because our pilot is located in Finland. There is a drop-down menu in the left side of the map, and you can select the asset that you are interested in. In this case, we have the Kontiolahti line, because this is our pilot. Of course, at the end, we will add more pilots and more assets. By clicking on and selecting the asset, the map zooms in the location of the asset, and you can see, here you can see the towers one by one. By pressing the right key, the right button of the mouse, you can have a 3D representation. And as you can see here, our line segment is a straight line. The towers are one behind the other without any deviation, as I mentioned in my technical presentation. And you can see from different, angles, a 3D representation of the asset. And after keep clicking on one tower, then a slide window slides from the right, where you see the description of the asset, 110 kilovolt conventional line, the year of construction. It was assumed that this line was constructed in 2020 based on the drawings provided by Fingrid, the asset owner, the description of the asset, where it is said that it is located in East Finland. It supplies around 100,000 people. The line is considered to be in rural environment. And also there's some information about the selected part, such as the length, which is 8 kilometers. The part is consists of 35 guide portal frame towers and some other information about the geometry of the line and the conductors. And then if the user press on the structural model characteristics, he or she can see the structural material. In our case, we assume that the material is structural steel S355. Also, the adaptation options that are available. We have decided to showcase the 3 different high-strength steel scenarios, which include the structural steel S460 and the asset fragility assessment approach. In this case, we have a cause-specific approach, meaning that we know the intensity measures. We have defined the intensity measures for the fragility assessment, which are the wind speed and ice thickness. And the BIM model locally in his vector. The material degradation is the next module where we can estimate the degradation model. And in this case, we have a steel tower, so we are interested in steel atmospheric corrosion, and we have considered the corresponding ISO models. And in order to estimate the atmospheric corrosion, we first need to choose one climatological model or more that are related to greenhouse gas emissions. In this case, we have used the SSP scenarios, and we have incorporated data for 4 different SSP scenarios. And after clicking on the SSP scenario, we have a graph which shows the zinc loss starting from the year of construction and reaching up to the year 2100, which is the end of century, and up to then we had available data. And as you can see, the material degradation module provides an estimate of the degradation of the asset's material, considering the effects of environmental conditions. In the selected power transmission line, we assume that the towers are made by construction on carbon steel, and a zinc protective layer on each member is also assumed. Thus, the module estimates the steel thickness loss, applying the models for steel and zinc corrosion under environmental conditions proposed by ISO standards. And we have also assumed that each tower member has a uniform initial zinc protective coating of 0.05 millimeters or 70 micrometers depth. And here you have the graph, and the user can interact with the graph by zooming in and out, and you can go and hover over a year and see the corresponding results. For instance, in 2057, and considering the SSP 245 scenario, we will have an expected loss of zinc equal to 5.9 micrometers. Also, you can eliminate one or more SSP scenarios and keep the one that you are interested. In this case, we'll keep the SSP 585, which is the worst case scenario. And as you can see, the worst case scenario, even at the worst case scenario, we will never reach the zinc depth, the zinc cover depth, which is 70 micrometers, because even by the end 295, actually 299, 295 is the end here, will be 11.7 micrometers. So, as we said, corrosion is not expected to affect the steel in this case. That's why there is no steel loss graph in this case, but in another region or with other climatic models, we may have also zinc loss. And also we have the life cycle assessment, life cycle costing module, which evaluates the monetary costs and other impacts, such as in terms of environmental impacts, like GWP. And in pilot 2, the LCACC assessed the feasibility of different adaptation options in tower maintenance and restoration after a failure event. Corbinian and David from University of Stuttgart made the corresponding presentation. And in this case, we have the scenario of no action at present, so or do nothing, which means that we leave the tower as it stands due to the low failure probability and also to the absence of corrosion. And in case of a failure event, 4 possible scenarios for replacing the failed tower are considered. The first one is to replace the tower with an identical one constructed by conventional steel of S355, while the rest 3 scenarios is replacing in the rest 3 scenarios we replace the tower with a new one made by high-strength steel of S460, and we consider 3 different scenarios with different masses, and the first one leads to a reduction of mass of around 11%, the second one around 16%, and the third one around 23%. And in order to estimate the LCLCC and show the graphs that were also displayed in UStud presentation, we first need to select one climatological model because LCLCC is related to the hazard. So we need to have to provide, the estimated hazard. In this case, we have integrated 2 possible climatological models, the EC-Earth RCP85 for the period 2040 to 2060, and the GFDL CM3 for the corresponding RCP scenario period. And let's select the EC-Earth. And then we need to select the impact category. As it was mentioned by UStud, we have 2 impact categories considered: the cost, and which is related to LCC, and it is the monetary impact, and the GWP, which is the environmental impact. And if we click on the cost, then a new graph pops up where we have all the corresponding, scenarios for rehabilitation or rebuilding of the failed tower. The first one, the red one, is the conventional do nothing and replace the failed tower by a conventional by conventional steel. The blue one is if we replace the conventional tower after failure with a high-strength steel scenario 1. The yellow is for the HSS2 scenario, and the green is for the HSS3 scenario. As you can see, different options provide different results in terms of cost, and it is evident that after 60 years, because in x-axis we have the expected life cycle of the tower, which is assumed to be 60 years, and we can see that under a life cycle perspective, the most beneficial scenario, especially after 25 years, is to replace a failed tower with HSS3, because we end up with a lower cost, and this is explained by the fact that the HSS3 scenario uses the least material, so we end up with lower cost. And for the GWP, we can get the corresponding graphs, and once again here the differences are not so large, but the most beneficial scenario is to replace the conventional tower with one of a high-strength steel using 22.75 less material. Of course, as in the case of the material degradation graph, the user can interact with the graph, can zoom in or hover over the points, get the corresponding values. You can eliminate one or more scenarios and keep the one that you are more interested. Now, the button, the next function of the platform is the scenario builder. And if the user, sorry, but for some reason I cannot. Okay. Yeah, if I press on the scenario builder, a new window opens, and I have two different options: the as-in scenario and the what-if scenario. Under the as-in scenario, you can display the results of the fragility assessment in a selected year, considering any possible material degradation of the stream members up to that year, assuming that no material intervention has been undertaken since construction. Moreover, the risk of failure, expressed as the mean annual frequency of failure, is estimated for the selected climatological model. So to do this, the user should follow some simple steps. First, should select the scenario from material degradation. Let's say that we get the most aggressive scenario, which is the SSPS 585. The year of interest, let's say that we're interested to see what will be the risk of the tower in 50 years from today, or 25 years from today, which means in 2050, considering, oh, I don't know, I select this SSP scenario and then the year, let's say 2050, and then I need, in order to estimate the risk at that year, and then I need to select a climatological model. Let's go with the ECF RCP 85, 2040 to 2060. And after making this selection, a new graph pops up which shows the fragility curves, which provide the probability of failure of the asset given the intensity measures considered. In this case, we have two intensity measures, the wind speed, which is depicted on the x-axis, and the different icing scenarios. I talked about that in the technical presentation, and here you can see the different fragility curves for the no ice condition, the PERC one, for considering ice 25 millimeters, 50 millimeters, and 75 millimeters. And for the case, and as you can see here, it is for the non-corroded case, because based on the material degradation model, even in 25 years for today, we are not going to have corrosion on the steel tower. And of course, the same applies to this graph. I mean, the user can manipulate this graph and keep the fragility curve on in which is interested. And at the end, sorry, I don't know why this happens. Let me do it again. And at the end here, you can see, probably there is a bug here, we'll fix it for sure. You can see the value of lambda, which is the mean annual frequency of failure. As you can see, it is very low. It is 1.5 times 10 power minus 4. And if I change the climatic model, for instance, let's use the GFDL CM3 for the same period, I will end up with a different lambda. You can see here it is much lower, and as we said in the technical presentation, the GFDL CM3 models gives better results and lower probabilities of failure. So this is the as-in scenario where you can estimate the risk. You can display the fragility curves and estimate the risk of the tower as built and as it stands right now and in the future, by assuming taking into account the effect of corrosion. But let's press the what-if scenario. In the what-if scenarios, we can assess the effectiveness of possible adaptation options. So for each selected adaptation option, the corresponding fragility curves are displayed. And finally, the risk is estimated by combining the adaptation option fragility with the selected climatological model. In order to do this, we follow similar steps with the as-is scenario, but in that case, we first need to specify the adaptation option. Let's say that I'm interested in the HS3 scenario, which is the one that uses the less steel, and as we saw in the LCA-LCC analysis, seems to be the most beneficial. Let's select a scenario for the material degradation, and I will select the most aggressive one, which is the SSP 585. The year of interest, let's say that I would like to see what will happen in 2080. And the climatological model, I will go with the AEC RCP 85, 2080 to 2100. And here we displayed the corresponding fragility curves. These are the fragility curves that were presented in the technical presentation. You have the probability of failure for different ice conditions, and you end up by the mean annual frequency, which is again very low. It's 7.8 times 10 power -4. So it is an accepted probability of failure, very low. But let's say that I would like to see what happens with the GFTL SIM3 scenario. You can see the estimated mean annual frequency is even lower. And of course, the user is not limited with the scenarios to select a climatological model that is related to the corresponding year of interest, but it is free to select also climatological models that refer to historical periods like the ECR 1985-2005. And as you can see here, I think that it gives a greater probability of failure, and this is possible because the historical, based on historical data, especially the icing thickness, is estimated to be higher than future periods, so that's why we have a greater mean annual frequency. And these are the information that the risk assessment module provides. The next module is the social parameters, for which Thanasis Yogas from RUG made the corresponding presentation. Once again, the initial step is similar to the risk assessment module. The user is redirected on the map, and there is the drop-down menu in the left side, where there are all the different parameters, the different variables that are related to societal characteristics of the population of the area of interest. Let's say that if I select the total population, then I have a layer here which shows that total population in each region. The whole country is divided into regions. And if I would like to focus on the asset, I simply, use this button here. And as you can see here, this is the line. You can see the towers one by one, and you can see the different region that the line crosses. And the red one is a highly populated region with a larger population than the orange one. And also I can display the rest of social parameters, like the number of females, the number of males, the age groups. This means that we have 42 in this area. We have between 42 to 5,180 people in the ages between 0 to 19. And this is the age class 20 to 29, etc. I can also, display the employment status. This is the unemployed, and this is the number of employed people. This is the number of retired people, the students, etc. Also the income. We have different classes of incomes, and we have also integrated the subjective well-being, which is a happiness index. You can see here the red ones, I think, are more happy than the yellow and the orange. This is the life satisfaction against the same colors, etc. And these, of course, all these data, thanks to RAG, are available and has been integrated for the whole field. So these are the two modules which are mainly targeted to the end user of the platform that have been already developed and are available in the platform. Of course, other modules will be added, such as the total risk and the module with the climatological models, where we can depict the trends in the main meteorological variables such as temperature, relative humidity, etc., for different greenhouse gas emission and what are we going to expect in the future. And as the last part of this presentation, I will show a little bit the asset initialization model. We should say that for this, in this module, only the administrator will have access, and it is the module which permits the administrator to enter or modify an asset. For instance, we have a dialog here with several fields that need to be filled. For instance, the asset name, let's put line here, the owner, the year of construction, let's say 2020. I can specify the asset location. I can upload the BIM model if available. I can upload relevant photos or files. I can select the asset material, let's say the S355. Regarding the material degradation function, I need to select the appropriate model. In our case, I will select the steel atmospheric corrosion model because we have steel material. The thickness of zinc layer, let's say that we have 0.07 millimeters or 70 micrometers. Here I am allowed to create a table with the concentration of chlorides and sulfur dioxide deposition. Let's say that in year 2003 I had 0.4 and 0.5. I can add a new year, another, let's say 2004, 0.41, 0.51, and by this way I can create time series of deposition of chlorides and sulfur dioxide. Regarding the temperature and relative humidity, they are integrated automatically by specifying the corresponding SSP scenarios. And for the asset fragility approach, we can use two different approaches: the cost agnostic, where we do not consider an intensity measure, and this was applied to pilot one. For whoever attended the pilot one demonstration can understand what I'm saying. But for the cost specific, which is in our case, we need to specify the intensity measures. We need to select the distribution functions that the fragility they are assumed for the fragility curves. So we start by estimating the intensity measures. In our case, we have two intensity measures: the wind speed and the ice thickness. I would like to visualize on x-axis the wind speed, so I tick this box. The distribution function, usually the normal distribution is the most appropriate for fragility curves. So I select the left normal distribution, and here I need to provide the parameters for the fragility curves and for the scenarios of ice thickness and degradation state. Let's say that I have not degradation, so if I have 0 to 0.25, and I use a Freddy name, let's say that in this case I have no icing, and the corresponding, fragility curve, let's say to 44, and is the median which being 0.19 is the dispersion. And if for this degradation state I have an adaptation option, I enable an adaptation option, and by using this, by pressing on this, I can define here my adaptation option. Let's say that I use the S460. I will say this is SH1. Let's say that the mass, the corresponding mass is around 2,400 kilograms. And in a similar way, I define the fragility curves and the corresponding parameters, and I can add fragility curves for different ice thicknesses, or I can add an adaptation option, and by clicking Save Changes, I save all the changes. And the last part is the hazard assessment, and for this part, we need to provide the generalized extreme value distribution for the wind speed and ice parameters. And in this case, we define the model, let's say the ECF. We define the reference period, let's say from 2040 to 2060. The wind speed parameters, for instance, we have the 9, the sigma parameter of the Z function. I use random now values, and let's say this is 30, this is 0.1, this is 0.2, and then I can, add a new climatic model and the corresponding parameters. And once I'm done, I simply place the initialized asset. Of course, at this time, this function is not, active because we have already uploaded and created the asset. So that's why I cannot show how I cannot initialize a new asset, but this action will be available for the administrator in order to add a new asset in the platform. And of course, by using home, I go back to the home page, and by clicking on this the door, I can exit the application. So this is the platform at its current status, and we saw the main functions and the main results as they are displayed. And of course, all this work incorporates all the technical work that had been done under core package 4 of RISKADAPT, namely the structural analysis based on the climatic data provided under core package 3 and the LCHS3 analysis. So I think that we are done with the demonstration and training of the platform. I don't know if you have any questions, and then, of course, if no one else has to add something, we may proceed with the hands-on session when it's user. You will be able to use this platform to log in and try, to play a little bit with the main functions of the platform that I just saw. So, any questions as for now?
Dimitris.
Yes, yes,
This is
Denise.
Hermes. Yeah. Hi. Just a comment from my side. Thank you for the interesting demo and for displaying the platform. Just one comment. So far, we as Nordic showed we have implemented and we have developed the risk assessment, the social parameters visualization module, the risk assessment module till the LCC, and the asset initialization page that for the time as this asset is already initialized, we have locked this. So in the next demo that we will have a third-party use, we will be able to display and experiment on this again. Further to this, what will be implemented is that we will integrate the results of based on the lambda, the risk identified per scenario. The user will be able to visualize the social estimation as Thomas explained before. And this will be provided as an input to RINA's module, the second part of the platform, that will be the total risk assessment, where the LCC results parameters, social parameters, and some other parameters that RINA considers will be used for the estimation, for the calculation of the total risk. That's all. Thank you, Dimitris, again.
So you are welcome. I don't know if there is any question. No, so I don't know, Marco, if you agree, let's proceed with the hands-on trace session.
Yes, yes, of course, that's fine.
So now all the attendees will have a more, active involvement from now on. So what you need to do is first to open the browser and go to a website that I'm going to send on the chat. Let's wait a couple of seconds. If someone has an issue, please let me know. So you may, read the text, you may play the video and show the instructions, which is the manual for this pilot. Of course, the manual PDF will be also created and integrated in the platform. And then after being at home page, you can select the risk assessment, which is an active module. And by clicking on the risk assessment, I hope that you got the map, that you are redirected to Finland area. And then you select the asset, which is our line. The maps move, actually zooms in the location of the line. By pressing the right key of the button, you can have a 3D representation of the asset. You can see the towers. Of course, we are missing the conductors, but it was a challenge for our designers. Maybe in a future version, we might add the conductors if possible. And you can also, by keeping press the left button of your mouse, you are traveling, along the line and the map. And if you would like to open, the description, simply click on one of the towers. I just click, and I have the window with the description of the line, the year of construction, the owner, etc. I hope that everyone can do this. I don't hear any questions or complaints. And then You can click the structural model. You can see the materials, the adaptation options, the asset fragility assessment approach. You can also, download the BIN. Then you can have the material degradation module. Click on one or more SSP scenarios in order, to display the graph with the zinc loss over time. And then you can manipulate with the graph, zoom in, zoom out. You can hover over the, the line and see the corresponding how the values are changed from time to time. I can also add more SSP scenarios. I can remove the ones that I'm not interested in. So I think that it's clear. I don't think that someone has much difficulty in working with the material degradation graph. And now let's move to the LCA-LCC. In this case, we need to select a climatological model. Let's get the EC Earth, and then select the impact attribute. Let's say that we are interested in the cost, and the corresponding graphs are displayed. Look how the cost is different for the different adaptation options, and also the time, the life cycle, the length of the life cycle plays a role. For instance, for short life cycles, we have some differences between the red and the blue line, but as the life cycle gets larger than 30 years, the red and blue line makes no difference. But also you can eliminate the options that you are not interested in. Here is just, a comparison between replacing the felt tower with a conventional one made by S355 steel, or replacing with high strength steel of S46 and using the scenario with the lower, the least steel. You can see that it is better to use the HSS3 scenario than the conventional one. You can change the impact. Let's see the GWP. Oh, sorry, there is a bug here. We should change the label of the axis. It should be GWP. Of course, our development team, which is great, will correct it immediately. And I can also use another climatological model. Let's see also the cost. Here you see how it changes, and this is, we are close to zero here because based on the GFDL self model, we have very low probability of failure. That's why the expected losses and costs are close to zero over the whole life cycle. So I will provide you some time in order to make yourself familiar with this part of the platform before we move to the scenario builder. And once again, you are more than welcome to make any question, or if you have any difficulty with the platform, please let me know. Now let's move to the scenario builder, which is very interesting because the end user can, play with the different scenario and the different adaptation options. And this is very important decision making when, is designing an investment plan for upgrading or upgrading the network, the power network in our case, the asset scenario. As we said, the first step is to select the corresponding greenhouse gas emission scenario, which is relevant, to the material degradation, the expected corrosion on the asset. I like to go with the worst case scenario. Then you have all the years from the year of construction, since the year of construction to the end of century.
Sorry, Dimitrios.
Yes,
I think I cannot find that page. I'm now in the risk assessment Kontiolahti, but the scenario.
Okay. Are you able to go to this page? I mean, to have the asset description page.
Yeah, but I don't know. I cannot see the scenario builder orange yellow wood button.
I don't know.
Yes, Marco, if you go further down, can you see the scenario builder yellow button?
Okay, I try to change the size. I make it smaller. No button.
I don't know if there is a matter of the browser. This browser is the Google Chrome. I don't know if you use
okay, I'm using Apple Safari, so maybe that's the reason.
I don't know, Themis, do you think that this might be the explanation?
I'm not sure. If you go further down, because you can roll down, but it might be also the Mac, the Apple Safari.
Yeah.
This might be also
I don't see the close button,
Yanis.
not the scenario. Yeah.
Yes, thank you, Vasi. Thank you, Thomas. Marco, can you please try with Microsoft Edge or Google Chrome?
Well, I have Chrome here, so I can try.
Okay,
yeah. Let's
try with Chrome.
Go on.
Thank you.
Okay, so let's wait a little bit.
You can go on. I will.
No problem. I think that we have plenty of time, so please look at it because it is very important. To know if there is issue with the compatibility of the browsers. Marco, once you're ready, please let us know.
Yes. Okay, risk assessment. Okay, now I get to Kontiolahti.
Exactly.
I got the map and try to click it, the line, but nothing happens.
So you cannot open the asset description window?
No.
Try to zoom in and click on a tower, a specific tower.
Okay, I try. Okay, yes. And now I see scenario builder and close buttons. So it was the browser. Yeah.
Okay, very interesting. So please, Yanis, keep a note of that. And now if you click on the scenario builder, I hope that you can get this window, the
Yes.
as-is scenario, the what-if scenario, and
Can also see. Yeah.
everyone selects an SSP scenario, whatever he or she likes, and a year, whatever again he or she likes. Let's say 2080, or let's say 2086. I will be 100 years old by that year. And let's select a climatological model. You can see here what are the expected fragility of the tower, given that we do not do any intervention by that year because we are in the as-is scenario, and we consider also the effect of the material degradation due to the climate, and also due to the climate, which is corresponds to the worst case scenarios of greenhouse gas emissions. And these are the fragility curves. Again, as we said, no corrosion is expected for this case, because again, the corrosion seems not to be an issue for that area. And you get the estimated mean annual frequency of failure, which if we had here estimated the return period will be a very huge return period, more than, I think it's 10,000 years or something like that. And of course, you can play with the different climatological models. The fragility curves will not change because they are not related to the climatological model, but the mean annual frequency, you can see here, it's different. And the same is also for the SSP scenarios, not changing the fragility curves, and this is because regardless of the SSP scenario, the corrosion, the estimated corrosion is minimal. If we had another tower in another location, in Greece, for example, we might have different curves here. You can also keep only the fragility curves that we are interested in. For instance, I'm not interested in the icing, so I eliminate these curves and I keep only the case of initial of soil no ice condition. But if I would like to see the extreme icing scenario, look how the probability changes. For instance, if I have 43 meters per second and no ice on the tower and the conductors there, the probability of failure is only 40%. But for the same speed, if I have 75 millimeters or 7.5 centimeters of ice accredited uniformly on the conductors of the line, the earth wires and the tower members, then the probability of failure is 1, meaning that my tower, my line cannot sustain, and with speed of 43 meters per second when I have 75 millimeters. And actually, the failure will happen in much lower wind speed, which is around, for instance, I will have probability of failure on 27 meters per second. This is very important and shows how the combination of wind speed and ice can, lead to disasters in power lines, and this has been described in relevant literature from past events. I have in mind some papers from China, and also a very nice occasion. It was not nice because a lot of people end up with a power outage for many days, but we had an event in Germany back in 2005, and that is one of the first, cases where the main research on that area started after that event in Münsterland, a region in Germany. And then, if you would like to go to the what-if scenario and play with the different adaptation options, what you need is to select the adaptation option. Let's get with HSS3. Again, you select a corresponding material degradation, a corresponding scenario of greenhouse gas emission for material degradation. The worst case, and let's select, pick a year, let's say 2060, and the climatological model. I will get this one, and then I get the corresponding fragility curves for the ice combinations. And as we said, in this case, our tower cannot sustain more than 60 millimeters of ice accredited, because it is a little bit lower and weaker in strength than the conventional are. But once again, given that the probabilities of extreme conditions are really low, we end up with a very low mean annual frequency, which can be acceptable. So that's why we can replace a tower made by conventional steel with one with HSS steel with around 22% less material and get an acceptable failure probability. And of course, if you will keep this value here, it's 9.8 times 10 power minus 7. And if I get the H scenario 1, the fragility curve change, and I get a very lower probability of failure. So more or less, this is the risk assessment module. I hope that everyone can use it, can interact with the different scenarios, and can understand the results. If there is any question, please let me know. And I hope it's time to move to the social parameters. Here again, once again, we have the map, the full map, and we can select the social parameter that we would like to see. Let's pick the total population. This is the different regions of Finland, the whole country. And if I want to see what is going on in the area of asset, press this button and the map zoom it, and I can see here the asset, the line. Of course, I can zoom in and out with the wheel of my mouse and see all the full length of the line, and I can select the parameter of interest. And of course, we will add additional parameters like the parameters presented by Thanasis, which are more, interesting. For the power line, we will also add, the corresponding answers regarding how affected the people will be by power outages. But this will be done in a future version of the platform. I hope that everyone can get the social parameter module and can see this map. I don't hear any questions, so I hope that it works for everyone. Okay. As I can see, the highest income is in the south, where the large cities are located, while as we are going to the north, we see lower incomes, or less people with highest income. And now, I don't know if there is a reason to go to the asset initialization since it's not active, but in any case, you can enter the asset initialization. Of course, this is only for the administrators, which will be able to add, delete, or modify assets, and then all this information like the asset name, the year of construction, the descriptions, the degradation functions. For instance, if I have a concrete, I need to define, to select between chloride induced corrosion of concrete, which is the case of pilot 1. We discussed about that in the corresponding demonstration, or the carbonated induced corrosion, which is the case of pilot 3, which will be discussed in early July in the corresponding demonstration. The fragility assessment, the co-specific, which takes into account different intensity measures, which are mainly related in climatological and meteorological parameters. And the user can, insert the fragility parameters, which are estimated by the structural analysis. And at the end, I think that if we put the fragility, we will also have the, which is not displayed here, but we will have the, the hazard also, a part where the user inserts the JEV parameters. And then by pressing initialize an asset, we will have an asset initialization, and then the asset will be displayed on the map, on the corresponding location, and then the end user will be able to make all the assessments, the risk assessments, see the social parameters, and also in the future the extra modules that we will add. I think that more or less this concludes the hands-on session. I hope that everyone had the opportunity to use the platform, to play a little bit with the current functions. I don't know if there are any questions, or our developers, especially Yanis and Themis, has something to add, something which I forgot. This pilot had a lot of background work, and we had a lot of functions included. I hope that I have not forgotten anything, or at least something that might be important. So please, Yanis and Themis, you are free.
Therese, thank you for the presentation, for the training, for the hands-on session. From RISA side, I think we are fine. We already made notes on some comments, and we are expecting now to receive the evaluation and feedback forms after you finish, to see any more detailed comments from the end users, participants. Marco, thank you, Dimitris, thank you as well.
From my side, I think that I'm done with the hands-on session, and we are open, to any questions, comments, whatever. We are more than happy to hear receive the feedback, and of course, then you will proceed with the questionnaire. So if there is any, question that anyone would like to mention now, we are here to answer.
Marco, any comment from you?
Well, I have a couple of small comments or questions. Well, I can say them now. For example, social parameters, it's quite nice to see the social parameters of Finland on this communal level. However, in the map, the scaling of the legend is not very intuitive. For example, this is the population, or if you again, because it seems that the scale is not linear, for example, so it's hard to make a difference. So there are very many very kind of sparsely populated areas, but I guess in none of the areas where there are people, because for example, if you take highest income, it's like €0, which is not very kind of realistic. But anyway, I guess you could make the legend more useful.
Marco?
Okay,
Yes,
thanks.
Dimitris, sorry.
Go on.
Okay.
No problem. Thanks.
Yes, the resolution on the legends was a methodology proposed by RAG, but we can further discuss it, with RAG to make it more realistic.
Just a comment, if I may. Probably, Marco, you misunderstood this legend is not the highest income. Sorry, it's not the income. It's the frequency, the people with highest income in this area. It's not the zero income. It means that there is no people or in this, for instance, in this region, in yellow one, less than 23 people are classified in the highest income. Of course, your comment is reasonable, and if another representation or another classification is more appropriate and more useful, we can discuss it.
Okay. So maybe you should kind of mention there in the figure also that what are the numbers, and I would prefer maybe have a linear.
But I think that the numbers are frequencies. Thanks, am I correct?
Yeah.
If I remember well, yes. But we will check with RAG, Marco, and we will have an internal call with them and try to meet this. Yeah.
Okay, I misunderstood that. Also, I was wondering with the asset risk assessment for the towers, when you consider the probability of risk, do you consider kind of the risk for one chosen tower or the risk that at least one breaks, or how you infer the probabilities? If you have 100 towers and the probability of failure for one is 50%.
No, in this case, if I get your question correctly, we are mainly concentrated on one tower, on the tower that we analyze. Of course, usually the failure of one tower triggers the failure of other towers, and especially in the case of a substation tower, we might have a domino effect. And if one tower fails, then the adjacent may fail or has a high probability of failure. However, given the time constraints and all the information that we had available, we decided to concentrate our work on one tower. So the probabilities shown in the module is for the one substation tower failing. And however, we decided to depict the whole tower, the whole line, because as you can understand, the span length and the configuration of the towers plays a role even in the probability of failure of a single tower.
Okay, but can you infer or interpret that, because if just one fails, the whole line fails, so
yes. Usually this is an assumption that is made, and there is evidence of that in past, in experience for past events. If I have a tower failure, then there is a domino effect, which we can have all the support towers failed by the first suspension, the first tension tower, which is the strongest.
Okay. Does anybody else have comments? One thing that I'm also a little bit thinking how to represent uncertainties in this case when we are basing our results on climate model simulations. So they do have uncertainties, and it's good to have several model realizations. For icing, we have only two, which is not too much, but still it tells us something about uncertainties. But what would be the good way to represent this? So it would be like we are doing now to show what different models would produce. But the other way would be that we could infer the uncertainty from the different models and not present the results of different models, but kind of different our best kind of understanding, so kind of mean of all models and some quantification of uncertainty. So it of course depends who is looking at the results, which is kind of more useful here.
So you mean that we could have, for instance, if I get your comment correct, if I go and have the risk assessment and let's say that I am in the as-is and select some scenarios to have, you know, a comparative like a table with a different mean annual frequency based on the different scenarios.
Yes, so instead of showing two different models, you just show the mean between the model and some uncertainty coming from the fact that they give different results. Of course, two models is not enough for this, but for example, if you would use Eurocordex models, then we would have 20 or 30 different.
Oh yeah, now I see what you're saying. Yes, of course, you know, the user can add as many models as he or she has it available. Yes, Demis.
Yes, Marco, we can further discuss upon this and how it would be implemented if it's useful. But yes, we keep your comment and.
But as far as I remember, regarding pilot 2, these 7 models, climatic models, the ERA5, the 3 ECF, and the 3 GFDL CM3 models were available, were provided by FMI last year when we were working on the structural analysis. So that's why we displayed those. But of course, there can be more if available.
Yes, of course, yes.
Yes, so my point was that what would be the best way to represent the uncertainty in the results? Good.
Okay.
So can we conclude the hands-on session, or is there more discussion on this?
Yes, I think if there are no other questions, and I think that we can conclude the hands-on session. And